Hello everybody, welcome to another stream. How are we doing? Yeah, so last stream we didn't really get too much time to work on the project because there was some interruptions and I had to bail early. So I did kind of like do a little bit more work off stream, and this is what we have now. So effectively we've only got one type of model being rendered, and I believe it's upside down actually. I don't know, I forget. It's kind of this one. It's meant to have like two ellipsoids, one which is horizontal and one which is sort of is vertical. And for now, I've just duplicated them in sort of a 2D grid, and then there's one that sort of sits on top. But as you see, as you sort of move around, they get a bit the ones which are in front kind of change, and that's just to do with the way we do the rendering code at the moment. It's something we can definitely fix in the near future. But yeah, I might save that one for after I've got the occlusion buffer sorted out. Yeah, I'd like to go over the changes I've made since last stream, just so we're all on the same page of what's gone on already. But yeah, I hope everyone's had a good New Year. Happy New Year. So I guess let me go through my Git diffs, see what I've worked on since last stream. So, right, I started to try adding type information to the encoder system. Yeah, I've just started that. It's not really finished. Right, what is this? We did that last stream. Yeah, the number of model instances was wrong. So that's why I wasn't showing all of the models initially. We have one thread group per model on this compute shader when it emits all the ellipsoids, and then 32 threads process 32 ellipsoids at a single time and emit those into some array to be rendered. And I was dividing it by 32, which was wrong, so that's why we wasn't getting all of the instances rendering. Then in the shader, we was using dispatch index instead of dispatch local index for the local index here in this variable. Oh yeah, that was it. So the normal was incredibly wrong to the point where it's showing sort of like black when you look to the ellipsoids from the top. And let's get Milton out, this will help explain it. So what was happening is if you had a non-uniform scale on the ellipsoid, and we looked at it directly downwards, the way the old normal code was working is that it would make this look like a sphere from on top or something like this, and then these areas would sort of show a sort of black in some places, but sometimes you'll see straight through it, and other times it'll hit the sort of like invisible black surface thing. So we fixed that glitch by properly transforming the normal from the local space of the ellipsoid as a unit sphere basically into world space using that adjugate matrix thing. I can't really go into the details of it, but yeah, it was that I think that was going around on Twitter. With adjugate matrix yeah, this is going around on Twitter by IQ, wasn't it? I'll drop that in the chat. But yeah, people typically do the inverse transpose, but it can be incorrect sometimes. So yeah, this method does it without the inverse. But to be honest, in the code that I've written, I've needed the inverse anyway. So maybe there's ways to get around that in the future. So that was one of the problems we fixed. Oh, we tried to end last stream. Yeah, sorry, before I had to abruptly end last stream, my ray trace anti-aliasing was wrong. And I had this really silly magic scaling number thing in here, but I managed to do the maths properly. But I can't explain it again. But I found out how to get what looks to be perfect anti-aliasing just by using the normal, the surface normal of the ellipsoid, and it probably only works for ellipsoids, to be honest. This sort of method. We could probably go into that quickly. So RTAA is what I've called it, ray trace anti-aliasing. So when we get the normal in world space, so you got your sort of camera, you shoot your ray, rays is obviously straight, and you get your surface normal, bing, that you've hit. And what we're saying is, so this is the ray direction is that way. We flip it the other way around. And we take the dot product between the two. So if they're 0, then it means if 0 is perpendicular, isn't it? If you've hit it something like this, and the surface normal is like that way, it went the same way as kind of the ray, so that'd be closer to 1. And what we're saying here is, we take the dot product between the two. We divide it by the square root. Yeah, this is the magic here. This decides the anti-aliasing alpha, whether or not we should continue on, basically. So this is the bit that I changed. Initially I had this sort of scaled. I could probably show it in some debug view. Initially I would times this by some scaling number, but it just wasn't right. It needed to be square rooted. Because it was a scale which was linear. It wasn't kind of making sense when you moved far away from the camera. So we get the size of the pixel in the near clip plane. So what's the size of the pixel here in the near clip plane? And then sort of just times it by the depth of the hit. So it will scale this up. Always a straight line. There's L in it. There we go. It's a bit big. Yeah, it scales it up to something like the size of that. And then it takes the square root of that. And somehow, I can't explain the maths with the dot product, it just seems to, and you clamp it in the range of 0 and 1, and that's the alpha, and it just works out. So we can see it with a debug view, maybe. So I think one take, repeat that a few times. And then we'll drop there's too many, isn't it? Drop a 1 in there for the alpha. Right, so be white if it is, oh, I kept paying, my friend. How are you doing? Thank you for the sub. 14 months, amazing. How's your new year? So as you could, tell, around the edges here, you get this like kind of like near enough for 1 pixel, maybe a couple of pixels. I've just taken a screenshot. It's gonna be a bit slow. So the whiter they are, the more alpha there is. When there's black, there's like no alpha. But yeah, I guess this could be a bit better around here maybe. But I don't know how jagged it actually looked. Well, to be honest, if I bring that up. No, we're not seeing that many grey, to be honest. Oh. Yeah, when it zoomed out, it definitely like still worked well as well. It's pretty interesting. See, I think it's pretty reasonable. Maybe we can fudge the number a little bit more, but that produces this sort of anti-aliasing around the edges at least, especially that one there. When I zoomed in on it, it didn't really look very jagged. So let's remove the debug view and put it back to what it is. So yeah, if I take this screenshot here, for instance, and then we'll do another one further away. I guess that looks like a jagged there. Doing good. New Year's fine. I stayed at home. Awesome. Did you go to bed early then? Right, I guess it's looking a little bit jagged, to be honest here. We wasn't seeing many, there's a bit of anti-aliasing there. We saw those ones blending. Yeah, this one really would blend. We saw it blend. We saw the cut, the whites. We saw this one would blend well. But yeah, the RTA is not going to be as good as proper like MSAA or super sampled anti-aliasing, right? But it's just a hack version which will just be quicker to calculate. But yeah, it's a bit of a hack. That was the idea for it. Anyway, that's still a bit jagged. So I guess when you're really close on some of the stuff, it's not that great, but we probably won't have that in this game anyway. But when you zoom out, I think it was like pretty reasonable. Take another screenshot there. Maybe even not this far, but it would just give us one a look. I'm not really seeing it, to be honest. Maybe a little bit here. But yeah, it's looking a bit jagged still. Maybe we could multiply it by something, but it's pretty close. Or maybe just change the... Yeah, we can think about it some more. But yeah, that was a change I made. Any more changes since last stream? What more things did we fix? No, I think that was it. Yeah, awesome. Yeah, so in today's stream, I want to get started on the occlusion buffer again. So we've done this, I think we've done this like twice in the past already. So we'll go over the one I want to do for this renderer and why I want to take this approach. So I jotted down on the Discord. So the current renderer, it has the ellipsoids sorted front to back already, and they're kind of roughly sorted front to back, hence why they sort of like jump when you move around the camera. We could probably improve that in the future. That's why I'm not worried about fixing that bug right now. I think we can fix it in the future. If not, there's another... Yeah, there's a couple of ideas I've got to fix it. So what we ultimately need is we're going to have an occlusion buffer. So an occlusion buffer is effectively you have the problem is in our renderer right now is you have a lot of so we just scale that down a bit. Right, so there's our view frustum. You know, you fire your rays out here. There's sort of the image where you rendered to. You have your ellipsoids out in the scene, right? And for each screen tile that we try to render, we have a little array. So these are like 16 by 16 pixels or whatever. It's a bit big, but yeah, it's not to scale, but it's just an idea. We sort an array. We roughly sort an array of which ellipsoids you could possibly hit within these pixels, and those get sorted front to back. Oh wait, 2 seconds. Just gotta help my boy get to sleep again. Hopefully not another last one. Right, I'll be back in about 10 minutes. Where's big come from? Don't know. Been gradually getting there. It's been an investment. Right, I'll be back in 10. Right, welcome back everyone. Yeah, apologies for that. My son needed help getting asleep again. But he's down. So last time he was a bit ill. Today he just struggled to go to sleep. So hopefully that's it from him. We shall resume now. Yeah. I think I need to sort out his bedtime when I come on and stream, because if he keeps interrupting, it'd be quite silly. Yeah, I'll think about that one. Right, so what was I explaining? Yeah, so I guess let's give a bit of a visual thing. So I'm explaining like how the renderer currently works. So what we're going to do this occlusion buffer. So basically, like, we're just rendering a very silly, stupid, like simple model, which just has this sort of glitch where we want to move the camera a bit like this. See how it sort of other ones appear on top when they were actually below, so they get rendered at different. Right. Rendered differently. That's just because the renderer sorts them front to back in a very silly way. So you take all the ellipsoids in the scene, the way it sorts them front to back, the current depth that is used is actually, you take the axis line bounding box in view space, right? You take the nearest Z, right? It's the nearest Z point on that bounding box, and that's what is used. So when you have overlapping ellipsoids, this can change just by moving the camera. And maybe there's ways to improve this. I was thinking when we ray trace for transparency, we just accept the glitch, right? So the limitation of the render would be don't overlap transparent objects. If you do, you will get glitches like this. Or if you do overlap them, just be worried these glitches will, exist. And then for opaques, when we hit an opaque, we just keep searching until we find the closest opaque hit, and we use that one as the final hit. And that will fix the problem. So I'm thinking about doing that in the future. And we'll actually probably do it for this occlusion buffer render that we'll see very, very soon. Yeah, parent life. Yeah. The thing is, though, he's usually quite good at going down at night. But I think he's got too used to sleeping in my arms during the day whilst I've been off. And he's had a few late nights lately that I think he's just a bit disorientated. But we'll get him back on schedule, I reckon. I think we're all a bit disorientated at the moment. But it'll be cool. So yeah, I think that's how we're going to fix this problem here with this overlapping thing being a bit wrong. But what we do is we then we take all those ellipsoids in the scene and we sort them by that depth, which is like the axis line bounding box Z, the nearest Z. And we sort them by tile, and then each tile gets an array of the ellipsoids which are sort of roughly in that tile. So if they, if this view space bounding box intersects this tile in screen space, then voila, it gets binned in that tile. So you have a dynamic array per tile, which we achieve that by doing a sorting algorithm. Basically, we just emit multiple copies of the same ellipsoid index into one big array, and we sort it based on the tile index and the depth, so that we get these dynamic arrays. done by just sorting, right? So one big array gets sorted, and then we get loads of little arrays of variable sizes within for each tile, right? So the problem with this approach is if you have tons and tons of ellipsoids which are not actually going to get shown, you're actually sourcing a lot of data which will never get rendered. So this is where the occlusion buffer comes in. So if we say have a wall of ellipsoids like this, right, which will happen, right? And then you've got some like fancy model over here, which is made up of these ellipsoids. I don't know what I just drew, but there we go. What we would like is, so we can do two things, right? The first thing would be like, we want all of these ellipsoids here to not even be emitted into the array which gets sorted and turned into a bunch of different arrays for each tile, right? And we also would like, you know, say this is a model instance, you just, before you even try and emit the ellipsoids of the model, you just check the model to see if the whole model is occluded, meaning it's not visible to the camera. So yeah, and we need to make sure as well, I think a third thing is doing this check is cheap and also doesn't have false results. If not, we're going to get graphical glitches. So the way you typically solve this is you get a depth buffer. So here's where this screen you'll get rasterized, right? Typically you have like a depth buffer, right, of the scene, and you basically just check the depth buffer. You build a depth pyramid. So the reason why it's called a depth pyramid is because this is MIP level 0, right? The MIP level 1 is like half the resolution. Just like that. And then this is half the resolution of that. This is half the resolution of that. This is half the resolution of that. Until you get one which is like 1 pixel. So that's MIP 1, then 2, then 3, 4, 5. So a full depth, a full MIP chain basically going up to, or going down all the way to maybe 1 or 2 pixels in size. And that means what you can do is you can take your, so this would be, I think we get away with half resolution, right, of the actual scene that we're trying to render. And then this would be quarter resolution, eighth resolution, 1/16th, and so on until you get to about 1 pixel. So you have this depth buffer of the scene, and you just simply take a 2x2 region, and this is like a well-known algorithm on the internet. I think there's a few resources for it. There's probably one on the VK guide, I think. But yeah, it's pretty common. .dev, obviously. Yeah, I think it's occlusion. GPU-driven rendering, compute-based culling. I think this is it. So yeah, I can drop a link for that if people are interested in seeing some other approach, which is kind of similar to this one. So yeah, you check, you find the MIP level where the size of your object that you're trying to check if is occluded. So if you've got a this ellipsoid, so if this is occluded from the camera, you get the crap happened there. Yeah, you get the access line bounding box for it. You project that into screen space. That was a terrible projection. Project that into screen space. Now you find the MIP level of the depth buffer, which is a 2x2 set of pixels. You sample these 2x2s, and then you take a max of the depth and use that depth to see if the maximum depth, so it would be here, right, or whatever it is, like here or something. It'll be something like this, right, where it's, so you always put the, something like that, the maximum depth. You check to see if this is closer than the depth of the thing you're trying to draw. And then if that is so, then that means it must be completely occluded, and therefore you do not have to render this thing at all. This just doesn't try to get rendered. So that's essentially what we're going to be building. We've kind of built a similar version in the past, but here's the actual plan. Now we've got some context. So you might be thinking, how did you create a depth buffer before you've even rendered the scene? So there's a few different techniques to do this. Some people take the previous frames. Some people take the previous frames, the depth buffer, they build the depth pyramid, and then they they try and render all the objects, and the ones that pass the depth test this time will get rendered. But the ones that failed get put into a list, and those will get rendered again with the new depth buffer, which has been made from the ones that passed the test. And then you obviously do the thing again, where you see if they pass the depth test. If they have, then you render all the ones that actually pass the occlusion test. But this one's going to be slightly different because I cannot render it twice, because the way my algorithm works is that I have things sorted front to back such that I can do the transparency thing. So I've done a sort of modified approach of that algorithm. So this is one that I came up with based on that approach. So we create the occlusion texture at half resolution. So half resolution, so it's going to be quicker, and we're not really going to want to have a full resolution check, because things aren't going to be 1 pixel in size anyway. So if you have something that's 1 pixel in size, we're probably just not going to render it. And we have a full MIP chain going down to 1 pixel, so we can check those things which are really big, basically, against that low resolution MIP chain. And it's preserved between frames, and it will resize. Resizing the screen will cause a resize of the buffer, and it will be zeroed, I think. Maybe it's a bad idea. Maybe it'll be infinitied. I don't know. Anyway, we'll question that again. So we've already got that resizing code. We do it for a few things actually already. The things that need to be preserved between frames, they have resizing capabilities. We've got that in the GPU API. So first of all, we only tile bin the opaque ellipsoids, since the transparent ellipsoids, and we don't want those to contribute to the occlusion testing, right? We only want to render opaques into the buffer. So obviously, you're not getting any optimization if you've just got a bunch of transparent objects over each other. Those will never occlude anything in the occlusion buffer. So we tile bin opaque objects that pass the occlusion test using the previous frame's occlusion buffer, right? So we still have that same sort of technique, but then we ray trace a half resolution. We ray trace at a half resolution, and we only write the depth out this time. So this is what's different. We only write out the depth and write that to MIP chain 0. Then we downsample that all the way to the smaller MIPs, and then we use that new occlusion buffer to then occlusion cull all of the ellipsoids and model instances for a full resolution one. So we're actually kind of doing the sort of tile binning stuff twice. So hopefully this still pays off. We can toggle on and off the occlusion buffer stuff, but from my testing, the sorting like shouldn't be that bad, because we're going to be minimizing the amount of objects that we actually sort, because the only ones that actually get sorted are the ones that pass the occlusion test with the occlusion buffer from the previous frame, right? And then of those which actually pass, they're the only ones that actually get rendered as well at half resolution. And then again, the ones that only pass that occlusion buffer will actually get rendered fully anyway. So I think because stuff is not getting, the amount of stuff that's getting sorted will be minimized, it should hopefully pay off. We've got a little profiler built in already, but I don't know if it's really good to draw the metrics from this, but if I press F4, we've got this guy. So I guess we've got some numbers to run off. So yeah, the sorting is this code here, the tile binning. It's about 0.52 milliseconds. And this is before we occlusion cull anything, by the way. And why is this a good test even though we've only got this many ellipsoids? Well, because it covers the full screen, and that's going to emit objects which cover all of the tiles. That's about 1 millisecond here. So that's actually, we're sorting 300 odd thousand objects, right? Because we're duplicating these ellipsoid indices into an array per screen tile, which is 16 by 16 pixels. So we visualize the screen tiles. They're actually, yeah, they're small, right? So we've got a dynamic array for each one of those. So there's gonna be a lot of these duplications everywhere. So yeah. So I might benefit actually by increasing my screen tile size anyway, and that will probably divide this number by about 4 or something. But the occlusion test would also not render the stuff behind these, because there's actually ones underneath. They're at the bottom here, see? It's a very terrible model, but you get the idea. So those ones, actually no, seeing it from here, they might render because they still peek up on top. But yeah, stuff to, but it will definitely help out stuff that are definitely behind this wall of things. So yeah, there's stuff to play about with other than the occlusion testing, obviously, like how big the screen tiles are. But yeah, awesome. Yeah, these are also quite big ellipsoids as well. I don't know how big our ellipsoid is going to be, but it's something I should play around with. Cool. Right, so I guess let's get started on this algorithm. So the first thing we need to do is actually start off by making the occlusion texture. And so it's a half resolution, and then we're actually going to render a depth. Do a tile binning pass, and then render only the depth into it, right, at half resolution. So I guess let's just get started with that today, and we'll see where we get to. So we go to graphics internal. I don't know if I've got an occlusion thing, and also I've done this in the past to some degree, so we'll probably be peeking at some old code and taking a look at that as well. Probably in a different editor, so I don't get confused about which files I'm looking at. So this is some old code. So like an occlusion MIPS count, occlusion texture ID, and MIPS base ID. That's a good point. So you need to, so because you can't, there's something like you cannot write to a certain MIP level because the graphics APIs are just weird. But you can read from a specific MIP levels. So the way you can write to a specific MIP level is you have to create a texture view for each MIP. So yeah, we've got to do something like that again. It's just the weird limitations of graphics APIs right now. So we'll put something like this in, occlusion MIPS there's the actual texture and the base ID radio. So the next thing would be we need to actually initialize them, so it'll probably be in here somewhere. So this code is definitely going to be different to our new one because we've got like resizing as well. Oh, how would it be? I think we just call it static or something like this. Ah, yeah. Right, so let's get to graphics.c. Do I have like a resize? GPU.h. Right, I don't call resize, was it re-init? Right, yeah, that's what I got. Yeah, so I can reinitialize the screenshot one. That's what I've done. I had to do because that's persistent, but it will change when you take screenshots of different sizes. Yeah, that makes sense. So, so we initially created it with a 1 by, yeah. So we want to basically, I think, initialize it with, so how many MIPS have we got for the occlusion texture? Well, it's just 1. And we're going to say, we just want to store a 32 float. Yup. 1. How many MIPS? Good point. Can that GPU texture in it? Yeah, the re-init can change the number of MIP levels. Amazing. So we just say 1 MIP level for now because we're going to reinitialize it anyway. Good. And so when it comes to this sort of like base, if we search for more occlusion-y stuff, yeah, there's this other loop here. We want to initialize all those texture views, but the problem is we don't actually have any so the max number of, we should probably put down a constant somewhere. What's the maximum number of MIP levels? Well, I think it's like 12 for a 4K screen. We'll have to have a look at that. Yeah, I guess I'll just dump it up here for now. Right, so it's be graphics, occlusion, MIPS, capacity, I guess. So this would be, I think it's 12. So I guess you're up to 4K, right? Yeah, I think that's right. So I imagine you need 12 MIP levels to do a full MIP chain from 12K. So we'll pre-allocate a bunch of textures or texture views, right? Up to that, and then if we exceed that in any way, I guess we'll just clamp it. And if we go over 4K, there might be some glitches or whatever to fix in the future, but yeah, at least it won't crash. So yeah, I think we'll just say initialize static, and we'll just do, for now, just be 0, number of MIP levels 1. Good. So write it. Yeah, so we just create them to be basically 1 pixel and always just point to the first one in this case. And now this is where the magic begins. So in render frame, right, when we render a frame, we need to be able to say, well, if the number of MIPS, I guess we could do it as part of the model rendering. I wouldn't mind doing it here, to be honest. So what we'll be saying is, let's just find where the, yeah, we should probably make a function for this. Yeah, we should make a function for this. So let's go into the GPU. Oh, for crying out loud, what did I do? Right, GPU.h, we'll call it E32 GPU MIP. What are we saying? MIPS count. Full MIP chain count. This is such a long name. MIPS max. Right. Dims. MIPS max from dims. That's a bit better. So getting some dimensions, 2D dims, right? Something like that. So the logic would be, GPU. All right. Let's look for that one. So the logic will be this. So take the most significant bit index, which is set from the dims.x, from the maximum number between the both components of the xy. So I guess that's also just max element. Then we just add 1 to that result, and voila. So we take that nice function and then it becomes a little bit more reusable, which is great. So this will be, we get the number of MIP, occlusion MIPS count, and you throw in the scene, GFX scene dims, XY, and you then do a minimum between this and whatever the graphics occlusion MIPS cap is. So this will stop it from like erroring if we have too many. If we go over like a 4K screen and it needs more MIP levels than we have planned for. So now we can say, well, if this one differs from the one which is inside the global graphics thing, then we have to resize the occlusion buffer and reinitialize all of the MIP texture views. Hey there, Spectre of Starman, welcome. Hello sir, Happy New Year. Yeah, Happy New Year to you as well. I hope you had a good celebration. Computer shaders are still my Achilles heel, so yet to successfully figure out how to call on the GPU. I already have multi-draw indirect going, so probably calling is following stuff me. Nice. Yeah, I don't know if you saw the link I shared. There's this one here. On compute-based culling, there's an article here about it. This one's quite alright to look at for some ideas. There's other ones as well, but I think this will give you the help you figure out how to search for more resources on it. What I will say though is if you having problems programming with compute shaders, is you need to make sure that you can debug your compute shaders very well. I obviously went and wrote a whole custom compiler which allowed me to do sort of custom printing from so from my shaders I can say GPU. Well, okay, my shader compiler is at hprintf, and I pass in the buffer to write out the stuff to, and then the format and then the arguments, right? And that will like get sent back over a storage buffer, right? This being the storage buffer. And then I read that back the next frame and then print out to the terminal. So I can print from the GPU, and it's amazing. But not, other shading languages don't really have string support. There are, in GLSL, there are extensions to do some printing. Maybe look into that. But I seem there might be some issues with that approach, but I'm not sure. Maybe it's fine. Other ways you could do it is you could just make a print function which doesn't have string support, and you could just say, make a function which is just like print U32, and you just pass in that U32. Maybe you give it some sort of hash ID, right, as a bit of an identifier, so you can sort of visualize it or see it back in the terminal. You know which print it is, and then you can pass in your actual value here. And then that can come back to the CPU, and you can actually debug your things very well. And obviously you've got to put if statements around these to say, well, make sure this is only the first, index being, make sure you're not just printing out everything, because compute shaders are highly threaded, right? But that's a very good tool to help you debug your shaders. Another one that I have as well in my shader toolbox is ability to draw shapes. So I can say draw 3D sphere, and it allows me to drop effectively a 3D point down in the scene. I got it in my CPU code and on my GPU code. And the way it works on the GPU is just, again, adds it to a storage buffer. But then later on in the frame, it actually gets rendered. So I can do this sort of draw 3D from anywhere in my compute shader code, and it will just draw stuff into the scene, and I can just visualize it. So that's a very powerful thing as well. So I recommend getting those two things in, and writing compute shaders would definitely be less of a headache, because it's like impossible to debug them otherwise. And we already have a good debugger support on GPU anyway. But yeah. So we've got a function called GPU texture reinit. So we're going to pass in that graphics occlusion texture, reinitialize this thing to the dimensions of the scene. Wait, it's a half resolution, isn't it? If we remember that. Essentially, maybe this will support up to 8K actually. Yeah, so what we actually want to say is like target. Yeah. Right. Occlusion dims. So that'll just be graphics scene dims. Right, so it'll be a shift right. Let's run it. By 1. And we max it by 1. Like so. Voila. Neat. So I'll go in there like this. Occlusion dims. Hey, Rosema, welcome. Happy New Year, sir. How have you been? Did you have a good New Year celebration? I'm a bit tired because I stayed up till like 1. And I came home and the neighbors were just going crazy still at like 1:30. So I had to tell them to shut up. It's just so damn loud. Just open up the window and then they shut up eventually, like 5 minutes later, which was nice. But yeah, it was pretty cool. Yeah, same, loud until about 1:30, yeah. Yeah. I understand if it's like till about 1, maybe, or about 12:30. Yeah, people are wrapping up. The hours were at 1:30 still going. And they're probably not going to keep going till, so, you know, kind of had enough. But yeah, there's that. I woke up so exhausted this morning. But luckily I'm not back to work till Monday. So I got some time to recover. There's got XY there in it. And then... Cool. Number of MIPS, well we've got these now in it. Number of array layers 1. Nice. So we've got to remember to actually make sure we update this, because if not it just gets updated every frame and boom, it gets resized every frame and we lose all our progress and everything. Now what did I just do there? I just made it equal to itself. Cool. So the other thing we need to do is reinitialize all of those texture views. So we get this for loop. This time over all of the occlusion MIP count worth of those, and base MIP level. Cool. So yeah, because we can't write to a specific MIP, because GPA APIs still can't do that in 2025 now for some reason. You have to create texture view, so in your shader code you can just get the texture and it's offset manually. Well, it's offset as part of the texture view, so when you write it in the shader, when you use it in the shader, it's technically the lower resolution MIP. Yeah. Cool. I don't know. Yeah, this needs to use reinitialize. So a lot of those variables will not work the same. So it'll be something like... Yeah, so you would say... Yeah, I wonder how I did that one before. Alright. Okay, we need to make another function in gp.h. this one is gonna offset it. Although, how is that gonna work? I got ideas. So it's done in an object pool, even though it doesn't have to be in an object pool anymore because we don't really deallocate things, but it's still in one. So we've got our resources pool. So it could just be an array these days, but anyway. What we need to be able to do is use, so I think we'll get the actual turn into an index, and then we'll take that index and turn that index. So it'd be object pool get ID. I guess you get it from a pointer. I thought there was another way to get or get. We can do either. Oh, no, we have to get an ID from an index, but I guess you could do it from the. I don't know what's going on here. Get. Yeah, we've only got. Sorry. So we'll pass in GPU resources pool, and then the pointer is you just basically manually get the pointer yourself by looking at the entries and offset it by the index plus the offset, and that should be all right. And I'll get you the resource index with the proper counter bits in the high bits of the ID. So we can use that to offset from the, so we can call this a MIP res ID just to make it a little bit more easier to read. Yeah. And the one that's going to be aliasing is the occlusion texture at that MIP level. Great. Cool, that'll work. That'd be very nice. Right, so now that we've reinitialized the texture when the resolution has changed, or on the first frame, this would also trigger. We need to make sure that the texture has now got uninitialized data in it. It is complete garbage, basically. What do we fill in that texture to make it make sense? So since it's a depth value, for now, we've just put full on U32, sorry, float 32s in there. Later on, we might use, we might pack it down into like a U16 and do fixed point. But yeah, I've not been concerned about doing that yet. So I think we want to do a texture clear. Cool, I've already got one of these. So we'll do a texture clear, and I don't think it's 0. So 0 would mean that nothing will pass because the depth is 0. So what we actually want is probably an infinity. So I think I can say float32.x is equal to infinity. The rest would be set to 0, but it doesn't matter because the way the Vulkan thing works is it only, I've only got one channel in there, so it looks at the first channel, which is the X, or it could be R, right? Same thing. Yeah, the one we're clearing is this one here. Now I'm hoping that's not going to clear the whole damn thing, but it might. Yeah, it clears all the MIP levels. Maybe that's okay. Be a little bit more slow than it. Yeah, maybe I should make a thing which like doesn't just clear all the MIP levels. It can just clear one, right, or one array slice. But yeah, it doesn't really matter. We can Right. We'll just, you know, it's an optimization in the future if we need to make it. So, cool. So, in the texture viewer, I think I've got some way to change some kind of, like, yeah, there's a mode, a view mode, like whether it's like a, I've just got a float mode, isn't it? Not really a depth anymore. Right, so I think it just works out fine. Yes, it should work out right. I don't have any specific ways to change this mode based on the resource. No, I don't. Okay. Right, so we should just be able to view that in the texture viewer now. So just give it a nice launch. So if we open up texture view of F9, open up a new tab, and it crashed. So this one's crashing because it's just a seg fault. Right, 1287. What's going on there? Line descriptor sets. Why is that crashing? Seems like some invalid states happen. Right, let's try that again. I don't know what causes that. Are you correct? What does that mean? Also, why is my game crashing now? It's just crashing anyway. Oh, maybe I'm just running out of memory. So maybe this is happening every single frame. You go about touching the mouse. Yeah, well, you know, I do use the mouse to sort of like point to stuff, I guess, here, and I do like to sometimes use the mouse as a bit of a break from the keyboard. But yeah, primarily use the keyboard because it's just more effective, right? This is more comfortable as well, typically. Although, as I said, I will take the break from it every now and then just to sort of have a browse like this sometimes. But typically, you can navigate a lot better with just the keyboard. And if you buy the bullet and learn something like Vim, or this is Helix. Helix is a bit more user friendly to beginners, I think. Yeah, you know, jump around, code pretty nicely. Quite like it. Just got to remember all the keys. But you can make up your own keys as well. Yeah, I'd say if I use a scroll wheel a lot, it can definitely like I could feel my wrist feeling a bit weird. Yeah, I do have quite a bad right wrist to be honest, and that probably a lot of that stems from the mouse, or maybe just even just typing on the keyboard in an incorrect way. I've since learned to avoid those things. I've also got these sort of like wrist things. So this one's for the mouse, so my wrist just sits there now. And on that mouse, which is pretty cool. And then I got this one for the keyboard, but also as well, my keyboard comes with this. So yeah, set that on that, and that's enough height for a mechanical keyboard for my wrist to sort of sit nicely and not worsen my pain anymore than it already is. Yeah, too much scroll wheel does that. I would love to use near Vim, but as soon as it comes to debugging breakpoints, I switch back to. Right, I see. Yeah, what I do is I will use GF, which is Knack's front end to GDB. It's alright, does the job. And I have a little breakpoint thing where I put them in programmatically and just compile them in. And I sometimes have like if statements in here for things, and I only trigger the breakpoint on an if statement. I find that quite nice approach. So all this does is use the on Clang it uses built-in debug trap, and then on Windows it uses on Linux, sorry, uses built-in debug trap. Then on Windows it uses debug break. And when you hit this in the debugger, it is not inside of a function, it's an actual intrinsic, and I think this compiles to like some assembly. I think there's a single byte. I forget what it is. I don't quite know what it is. Maybe it's 8. In x86 it compiles to like some single byte instruction or something, I think. And it will just calls a debug break, which is pretty sweet. And that's the way I typically do it. I don't debug inside an editor. But yeah. I think I'm calling this every frame. Right, let's see if I am. So if we see yes you are every frame, then I'm calling it every frame. Have a gander. No. I only got called once. Interesting. So why then am I only... Was I just not running the game for long enough? I think I was running the game for longer than that when I was showing off some demos earlier. So I don't think we are... Right, so apparently whatever I did... Okay. So just simply by doing this once caused some invalid state to happen in the Vulkan driver or something like that, and then it crashes. So I think we could also never run this for loop, and then see what happens there. We should clamp that between 1 and 1 as well, yeah. Alright. Crashes right away there. In the first frame it will get triggered, then 2 frames later it's like, no. Right, so I think what's happening is there's a deferred delete going on. And what could be causing problems to the 1x1 texture or something like this. Maybe. Ooh. It didn't... We've not reinstantiated all of the... Right. Maybe we need to reinstantiate all of these texture views even if they're not being used. Because they're still pointing to the old occlusion texture. I think that's the bug. But I was looking at 1287. I don't know why it'd be crashing here. But up here is where it does the defer delete. But yeah, I think it's something like that. It's not defer delete in the image views or the texture views, right? So I think if we actually make this go up to the occlusion maps capacity, initialize them all, but we make sure we clamp this, so we min it with occlusion MIPS count take 1, and that will mean that if you go further than, if you have less MIP levels than the maximum number of MIP levels, the ones that come after will always point to the one at the back, or the highest one, which is at what's another way of saying it? The smallest one, which has actually been made. So I think that's the problem. Right, seems like our suspicion has been verified as... Yeah, okay, seems like we fixed it. Right, so something to note. Cool. Well, so let's explore the texture viewer. Should be a new occlusion. Why can't it scroll? Alright, because the scroll bar is not even... What have I done? My scroll bar's not even working. I think that's to do with DPI. I've not tested DPI that much since we use a 4K screen now. Right, that seems to be alright. This is infinity white. We can't really... So why is it 256 or anything above 256 is going to show up as white? I can't bring the white value down and make it more white. It won't make any sense. Can't bring the black up and make it more black. It doesn't make any sense. I don't have a way to change these. But yeah, they're initialized to something like infinity, which is cool. And we can look at all the MIPs. You know, you get down to MIP 7. Oh, it's a bit small on it. I thought this worked a lot nicer. I thought I had code which handled that. You know, let's switch back the DPI and see if right, so if we go to UI.c, see if we can fix a couple of things here. There we go. So if we put this to 1 instead, it does 2 because it's like 4K and I've got 200% scaling on. Oh, I've got 2 cursors. Ah, silly me. Okay, so we see, let's see if we get those 2 bugs that we were having. So in the texture viewer, pop that up, it should be really small now. Right, so we turn this. Yeah, see the scroll bar works here, right? That's what you want. So there's something wrong with the DPI and the scroll bar, we can look at that. The other one was the occlusion texture. When I change the MIP level, right, it's not recentering. I thought I did solve that problem. I thought I honestly had that problem solved. Yeah, that one's alright, isn't it? Right, so that's not to do with DPI. Cool. So see if I can quickly look at that. Scroll bar. So scroll, is this scroll area? Yeah, so somewhere in here. I think the list, there's a list view as well, probably it's a similar problem. So it's like a content space thing. Probably just got multiplied by the DPI. Inner area dim, scroll bar width, padding. So I think we'll scale this by DPI. What other ways? So that's the inner area dims. What's that used? Right, content size. Okay, scroll max. So yeah, that's what's going to be scaled by DPI, that thing. Yeah, so I reckon this has to be scaled by GUI DPI scale. It's one of the things. I think there's some more though. So scroll bar X, that's the bottom bar. What's the width of that? That's already DPI adjusted. The ratio, that's DPI adjusted, I think. Although, what would my content size be? Can I find that in the... Wait, it's a list. Right. Let's not fix this because I'm not going to have a way to sort that out. It's in a list. List is a bit easier. Yeah, so list has a scroll bar in it as well. So... Right, the list state holds the item height. So didn't I scale that by... Has there been no DPI or whatever? There hasn't been. Interesting. So I think we need to scale the... In a list, we definitely need to scale the item height. So this item height here, I would say, needs to be put into a nice little local. Well, so it'd be list state, list item height. Sorry. Item height times by GUI DPI. Oh, what's up, mans? DPI scaling, right? So every single time we see this being used. Just use the little local instead. And that should help with some of this maths going on. I don't know if that's the full fix though. Cool. Let's just double check see if there's anything else. So that's fine with the DPI because it's just the rectangle. It's not an actual width or anything that it needs scaling. That's scaled. This is already pre-scaled as well. This is just a number of items. It's not anything to do with the size of a thing. and that's already scaled, which means this is scaled. Cool. Wait, did we have anything that... No, this value didn't get changed. Good. Right, so... scroll bar height, that's an interesting one. Oh, where did I... Oh, okay. So, scroll bar height is that times content. So that's already scaled. Which means... Right, that content height is item height times that. So these are all been scaled as well. Yep, that seems all right. Yeah, I think that's okay. I think that'll fix it. Let's give it a go. If not, we'll just keep digging into the code a bit. So we see now with the texture viewer. Yeah, the scroll bar is sorted out. There you go. Boom. Amazing. That means as well, then when we view the occlusion texture and we click this, still not the right height. So that sort of height, there was someone else needs scaling. Yeah, I wonder how I define the size of that popover when you click it. Wait, that's a combo box, isn't it? Interesting. So that is a popover, doesn't it? Yeah, popover end. Yeah, popover start. So the dimensions are the item height. Right, that's not being scaled, is it? So again, we need to do a similar thing with the item height. So equals state multiplied by the GUI.dpi scale. Oh crap, but then... Yeah, that needs to be unscaled. That needs to be scaled. And then some of these actually might need to be scaled as well. Yeah, all the viewable values. Right, that whole thing needs to be scaled then. So this whole thing here needs to be scaled by GUI DPI scaling. That'll sort it out. Yeah, there's a few different ways you could do DPI scaling. It's just the way I've decided to do it. Oh crap, I pressed screenshot. Let's wait a few seconds. 4K screenshots just take a while to write out to disk. Also, that scroll bar is quite slow. Right, that's a nice size now. What about the occlusion one? Yeah, it's much better size. Scroll bar's really slow though on that list. So maybe we can... This sort of, the amount we scroll by can probably be scaled by the GUI DPI scale. Right. So we'll look at that. Mouse wheel control, isn't it? That's not mouse wheel controls. As if it's pressed and held down, and we're not fussed about that one, I think. Right, where's the other time we get to do this? The mouse wheel controls. Let's just search for that. Scroll area, here we go. Here it is. So D16 multiplied by the DPS scaling. That should do it. So that should fix the speed of that scroll. Just being good. A bit better. Just click on the... Yeah. Nice. Right, so now we can carry on with that occlusion thing again. So now we've got the occlusion texture, got its MIP levels. Let's just try and render the depth to it. It's half the resolution, right? As you can see, our resolution, if we open up the profiler, is kind of this 3000 by about 1700. But this dimension here is 1500 by 800, right? So let's just render some depth into that. So we need to write a new shader for that. Well, a new set of shaders probably. So we've got to mimic. So we probably... So we actually need to copy all of this. So we need to go over all the model instances basically, and find all the ellipsoids, and then yeah, but it's different. We only need to. We only want to find the opaques. We don't want to find any transparent ones. So we could probably put this all into a function, because we aren't going to call it twice. And it is just a lot of code to duplicate. And then maybe only a few things will change out. But we're not going to be running this ray tracer, that's for sure. But all this tile binning code, we are... actually, it's not that much to copy. This tile binning code, maybe... Yeah, let's just copy paste it. This is the way. So before render models, why don't we make another function? And we'll call it occlusion buffer. That way we can not sort of infect, just get lost with the code a bit, I guess. I do like big functions, but yeah, I do see this could get a little bit confusing fast. Maybe there's a way to make it good at all in one function, but for now, this will help us out in the short term, which is what we need. So we're going to render only the depth out, and it's slightly different. Yeah, so render models. So before that, we do the render occlusion buffer. Nice. Yeah, am I asked to use version control? Yes, I'm not that crazy. Although I'm not really the biggest fan of version control. I think that it is very complicated, and I'm not real into it. So I don't know all the ins and outs of how you use Git. Not like an advanced user. I'm a bit of I know the basics. So what I typically do, since it's just me on this project, I will just commit, push, and I tag it for the stream, so people who are who watch a stream might be like, oh, what was that commit? They can go and get that one. Yeah, if I'm doing a new project, I won't even use version control because I'm just playing about and testing out ideas. If I get to somewhere where I'm like, oh, I kind of like where I'm at here, I would copy paste the folder, and I'll put the folder, I'll copy paste it somewhere on the hard drive and keep going. I don't really program with the version control system and be like, oh, yeah, like I don't typically make mistakes enough where I want to sort of like go back to a previous commit. I know people that make a small change and they'll do a commit. I typically don't have that. I try and think my stuff through ahead of time and try things out, or I copy paste the code in the same code base and keep the old code there and always just be able to switch back to the old code if possible type of thing. I don't rely on the version control system as this thing because I find the whole like interacting with them very complicated and very error prone to the point where you can lose work. So yeah, I kind of avoid them as much as possible really, but I do use them. I commit my stuff pretty regularly for this project though. Usually every stream or every other stream, depending on how far we get. I also have batch scripts for copying project to Raspberry Pi. People don't like that at all. No waste a lot of space. That's all right. Yeah, if you haven't got a big project, just do it. But when you start to work on a game with like asset files and stuff, you're gonna need a bit more of a complicated solution. But if you just got a basic game, maybe it's just a 2D game, you're probably just fine. I don't have any problems with that. I think version control systems are just complicated. Yeah, so we'll recreate the occlusion buffer if the screen has resized or is initialization. Or is first frame. Cool. I don't usually put comments in, but sometimes they're useful. So go over all the models, and this will final load model, I guess. The problem with this is we do this twice into the same buffer, which is problematic. What is this generating again? Well, from model and model index, right? Not really packed, but it will be packed in the future, I swear. Of course. So we upload those and then we go over all the models. Right, so this is like preparing all the models, but then really the models will be a occlusion code in the future anyway. So what we probably want is a way to say, hey, take all the models and upload them to the GPU. That's actually a separate function again. I'm just creating too many functions. I hate too many files and too many functions, and this project has many of them. But there we go. So we probably want to call this like upload models. So yeah, I guess this will not be duplicate code. So upload me some models, please. I don't think I need that in a... Upload model instances maybe is a better one. So we'll do that. And be sure to adjust this function and delete the stuff we just copy pasted from the other one. That was exactly the same, right? So let's get back to what's going on there. Model instances, right? So the model instances need to be stored inside a global. Model instances count. So we'll set this up. And voila. So wherever we see this in the code base, we simply just gfx it. Like so. Right, so very nice. Now, so this is the render occlusion buffer. So this will take the model instances and then emit the ellipsoids. So maybe we should take a step which would occlusion call them in the future, but for now this will do. This is going to emit them into the render ellipsoids buffer, which is probably okay to reuse that one, I reckon. Yes, the render ellipsoids buffer is what is passed into the tile binner. Yes, these are ellipsoids to render. So we could probably reuse that function there. That'd be great. Tile dims. So 16 by 16 on a half resolution. You probably want this to be different. Although, so where is this going to be used in the shader code? It's obviously going to get used here in this bin. So maybe I need to pass it up as a push constants thing. And then if I do that, maybe this code could just be a function that we call, which would be basically bin. Oh no, but you only want opaques. You don't want any transparent ones to be rendered into here, isn't it? And also the screen dims would be sort of we wouldn't know what they are. So I'd probably make a function called like bin ellipsoids, and then that will get called. Then we could probably get rid of all these damn functions. Maybe. So we have bin ellipsoids, and then maybe you could pass in like, hey, what is the resolution of this thing that we're trying to render? But then like, yeah, and then I wonder where this is being used in the shader code. And it might just be better off being passed off other push constants. Yeah, just the bin objects one. Oh, right, and in the SSA. and MSA, ray trace, and RTAA. Right, that obviously makes a ton of sense because it's looking into the tiles, right? So maybe, just maybe those can all get it via the push constants, and then should be a lot easier. Hello, study computer science, and we have programming with C. I have problems with logical thinking and problem solving. Do you have any tips for it? First of all, it's pretty cool that you're programming in C, especially in computer science. These days, I don't think much computer science goes on in computer science lessons, so that's pretty awesome. What country are you from, by any chance? Because in the UK, I don't really see a lot of that. I've heard Sweden's quite good. But yeah, I'm interested to know about that. Best thing to do is just get practice. Find little projects which interest you that are actually small. That's a very hard thing to kind of do a lot of the time, especially when starting out. And start practicing, and then throw the project away. By throw away, I mean just move on to the next one. Don't care about the old code, but you can still keep it, obviously. And then program the next little project. So you probably want to spend maybe a couple of days on it, and you just keep practicing. And the reason why I say do something that which interests you is because when you have something that which interests you, it really drives you to, like, actually do it rather than doing something. And when it's something that's interesting you, you have more sort of, you'll practice things which are kind of more realistic rather than things which are kind of made up, and you don't really know if these things are actually helping you in the long run. So I guess I can give you a clear example. If you're into making games, which I guess is the reason why you're here, look into Raylib. It's a very simple to easy to use library, and they have lots of examples. You might have a bit of a problem trying to get it to link and stuff like that, but everyone goes through those problems, even developers who have been programming C for a long time. But there's lots of tutorials and there's a Discord to help you out. There's tons of people on there, but as an example, there's a sort of 2D platform here where the camera follows the player, and you click on these examples, and when you scroll through, you can see that all the code is here to do that, and you can just tinker with the code and achieve what you want quite quickly. It's not a lot of code. You could probably figure it out even quite as a beginner, but maybe it might be. But yeah, you can make, I guess I can give you two examples. Brick Breaker, just do a Brick Breaker clone, but your own spin on it if you want, or just do an exact clone. And another one is Snake, that's another one, or Asteroids. These old classic games which people used to write in assembly, program it in C. But yeah, there's 3D examples. Don't get started there because 3D is definitely a lot more complicated, but a lot more maths involved. And but yeah, just get started with very basic 2D sort of one, and have some fun. That's what programming is about, really. Get learning. Awesome Voodoo. You can use nuggets to link it, right? Fair play. Thanks, Raylib. What's wrong with Raylib? It's a nice little library for people to use, and they can learn C development in it, and prototype stuff pretty quick. Yes, I might make a, let's get rid of these. So these will instead go up as, you see, I wonder. Right. Cool. Right. So first of all, let's get rid of these from the globals. They're now going to be passed up via the push constants. So what I probably want to do is make another function, which I'll sort these functions in a second. This will be known as bin tile bin ellipsoids. So that will do, it's going to take some parameters in. Just got to figure them out. That will do all of this. Just got to figure out some of the nice. So does the occlusion culling, or will do eventually, emits the ellipsoids from the for each of the model instances. Bins them into screen tiles. Sorry, starts the tile binning process, generates all the entries for each tile, for every single ellipsoid which overlaps that tile, or those tiles. In the end, we'll actually sort them all into place, and I'll have all these different arrays. So what is different about this between the two things? So the thing is we've got this sort of, how many parameters do we need? We need tile dim, we need the grid dims. We need, so this could probably get done outside the function. They get passed up into this function, this shader here. And the overall, this is like the debug stuff. And that debug stuff really could be done out, just outside. So I only need 2 parameters, and I probably need a third to say, do you want to render opaques? Allow, this is a third parameter, so like allow a. So E32 tile dim, E32 times 2 tile grid dims, and then a third parameter which is like allow transparent. I think that's how you spell it. Nice. Right, so allow transparency. So I think that'll get passed into this one, so we'll not emit any objects which are slightly transparent. Or sorry, which are transparent. So just chuck that in there. This all comes out. So in the occlusion buffer, that'll go in there like that. Graphics, get out. Right, graphics, tile bin ellipsoids, the tile dim, tile grid dim, and the allow transparencies, that'll be false. Typically, I should probably name it so it makes the code a little bit more readable, so people don't just look at the code and be like, oh, what does that false mean? It's the problem with booleans. So sometimes I make enums for them, other times I guess I just make a quick local. So, alright, Calculate based on screen resolution. Yeah, Future Henry is going to solve that one. Real good. So this needs to use the occlusion dimps. Alright, much better. Cool. So I didn't finish up with this function here. We also need to make sure that we pass them both in here. So BC tile dim equal tile dim, and then followed by the tile grid dims. Nice. Let's get in there. Ugh. I haven't got a shortcut to get rid of my multi-cursors. I need to work that one out. Alright. Yeah, so inside the actual shader code, so shader. Right. Is there a grid dim in here? There it is. Cool. Right, so that's good. And then I also need to change it for the I'll do that in a minute. For the ray tracers, you'll sort that out in a minute. Let's just get this done. So model instances emit. We want to allow transparency. So we don't have booleans because booleans are a byte and you need to support 4-byte things. Well, they're not binary compatible. Yeah. So allow transparency. So in where this is inside graphic shaders, we want to say yeah, so right now I don't know a way to check this. Yeah, we should probably have transparent what count being different. We'll have another count for transparency or something like this. And then that way we can know and have if statements in here. But that's a problem future me will solve. You know, so current me can just get on with it. So at that point you may as well shield one of the many bad DL3, D11 APIs over Vulkan and Metal. Then what exactly? Copy paste some demos and with target audience of people already too dumb to deprecate evangelical profile. Right. Yeah, but these people, these people, right, would rather learn like how to program or how to sort of program a game and just sort of like not get lost in engine development, but still sort of want to learn the low level side of things, and they can gradually get there. So Raylib's like a good first stop, right? Because it gets you programming in C, it's used to C. Then after that, you can go down to SDL, and maybe even just stick with SDL. Some people do that, and then you can target all these different platforms. And then after that, if you could skip SDL if you want, but if you still want to learn more about how each platform works, you can go and just do your own thing. I wouldn't say these intermediate steps are a bad thing because sometimes you just want, like, you want to see results before investing just so much time just learning stuff about Windows, Linux, OpenGL, or Vulkan, or, you know, which are very complicated things, right? Right, okay, so what would you say then? So you say it's dead end. Yeah, sure. It abstracts over a dead API. Right, we shouldn't really be using them anymore, but put it this way, Vulkan isn't the easiest API to learn. Right? No one teaches people how GPUs work before, how you expect to learn Vulkan, you've got to read the spec. Well, the spec is huge. When you read the spec, you're like, yeah, but how does it actually work under the hood? People get lost. These things are complicated, they take a lot of time. How would you say to a beginner they get started in game development if they got to go ahead and do all this stuff? What would be your suggestion? BGFX, FNA, go pick a toy C Sharp project, the list goes on. No, but then you're admitting defeat. Like, Raylib gets people's foot in the doors using C and understanding C and why C is good, right? You're just basically, what you end up doing is all those people which go engine people, these hardcore people which just say to everybody, oh, you're not hardcore enough. That's literally what you create. Like, not everyone's like that. Like, you see tons of people on the internet who are C sharp and, like, do their C sharp or game maker thing, and every time they hear about an engine dev who programmed it all themselves, they think of them as this person who just, is too big headed basically. And anyone who doesn't do it, is not good enough or whatever, right? And that's not true. I think everyone should learn C development and understand it. And especially if you're on a 2D game, I think you should make your own engine and have full control over it. Not pay someone else a license, not pay for anyone else's license, and have full control over your engine, and to have a very, simple code base of people that you can work with and enjoy. There's a lot of benefits to having your own engine, and you can use SDL just to get all the old crafty platform stuff out of the way because you're not interested in solving that problem, and that's okay. Like, there's different levels that people are willing to accept when it comes to low level programming. And we shouldn't just be saying to them, go and be this high level developer if they're interested, right? Because over time they might get more into it, right? And help other people get into it. Mm, yeah, I still don't get what you're saying. I think you're just being too egotistical, basically. I think you're that person which people are complaining about all engine devs being. Yeah, but people are not picking up Raylib and being like, oh, this is how graphics programming is. They're picking up just to sort of learn how to make something in C. What's the waste of time about that? But also, when you pick up Vulkan, right, it's kind of crap anyway, right? Oh, this is how GPU programming works. No, it's not. It's some piece of crap abstraction that's a group of people made, and it's all a load of crap. Like, so, you know, I wish there was something better that we had. Like, everything has its own problems, and the problems that these people are trying to solve is not. Like, they don't want to learn all this complication just to get something going. Yeah, but BGFX is also, you could pick holes in that. That's just a wrapper around. BGFX was designed for OpenGL, which is an old API, doesn't give you the access you want, right? They've all got similar problems to Raylib. Yeah, they do. They're all just abstractions. They're not that great. Yeah, it probably is, but that's fine. These people would probably better off with that API. Anyways, I'm done with the conversation. Right, render occlusion buffer. So cool. So yeah, we called that guy there when it needs. Doesn't need, so we'll put a different ray tracer here, so we'll come back and do that. Nice. So when it comes to rendering the models, that will ultimately do something like this again, and be allowed transparency and be true this time. So we won't need this because that's part of the function. This function now. Yeah, actually it's just here in it. All right. yes, that's the scene dim. So you do the tile bin, and then so that's part of this call here. Now this shader here needs to pass in these two bundle constants like so. Nice. So I need to get those in here as well. So shaders. So ray trace. Here we go. So we do it in here a few times. All right. So yeah, I don't think we do it too much. So we just do it to work out the tile coordinate from the pixel coordinate. You know, a tile stores many pixels in it. And then we get the array of ellipsoids for that tile and then go over those. So we've got three different ones: super sampled anti-aliasing, multi-sampled anti-aliasing, and then the ray traced anti-aliasing thing. Yeah, but Raylib isn't meant for making such amazing thing with ITXNA. It's meant to just make little prototype things and to learn, right? It's a very quick and easy API to use. You see how much code people can use to make something in it? It's not a lot of code. That's the reason why people use it. That's what people use it for. I won't use it because it's not anything I want to do. Like, it's not meant to be a rendering API. It's just, you're meant to just sort of like drop stuff in and, you know. But they've added shaders so people can do more stuff to it. So. Yeah, so now we're at the point where I think we need to actually make that other ray tracer. So we're going to make one which does only writes the depth value out. So that's the next one we need to do. Yeah, but all that person wants to do is learn how to program in C, and when you give them a nice easy API to like put stuff on the screen, what's the problem with that? Like, they're going to get to learn their C and express stuff visually, nice and easy. Why wouldn't I use it? Because I've gone through all the hard work of doing it all by myself and using. They're going to start off on SDL2, I think. So yeah, I just started off one a little bit lower than that. I used SDL renderer before, which was their little crummy toy renderer API on top of OpenGL, which couldn't even do sprite batching. There's different levels people are at. I don't know why things have to be super hard for someone who's just picked up programming for the first time. Yeah, it's just silly. Yeah, I guess he had an unhappy New Year. That might be it. He's got to spread his unhappiness across the internet. Um. Right. So where's the ray tracer bundle constants? That's in. Alright, ray tracer. Not that one. Rightio. So what I want to do is we can call it the depth ray tracer. So we're just going to write to the depth texture. Go over all the ellipsoids. Probably just write out. Nice. Very nice. So let's find the ray tracers wherever the hell they're at. Alright, here's the SSAA one. Just take that one. Take that one for a spin. It's just a simplified version of this. Oh, what happened there? Happy New Year, MD sub. Ah. MD's Ubuntu. I could have just done that with a better shortcut, but anyway. Okay, I guess this now gets the ban. What a weird geezer. I think I've seen him in the past, and it's definitely not been like that. You know what's got up his trousers, I guess. Alright, depth ray tracer. We could call this the occlusion ray tracer. That might be a better name. Yeah, that sort of thinking, though, to me at least, the way it came across was just the reason why you have people who are just using like Unity, Unreal, or Game Maker or whatever. We'll look at engine devs. People make their own engines, and these guys are all big-headed. You know, which is a shame. Yeah, well, I hope the guy didn't get turned off. I hope he took the advice. Right, so we get the pixel coordinate doing this Morton swizzle thing, so they're arranged in like every 4 threads, they're in a 2x2 set of they're in a 2x2 grid of pixels. So it's ordered in a Morton Z curve. If you don't know what that is, you give that a Google. We get the tile coordinate the pixel is in. Then we extract out the array, the range of the ellipsoids, which represents a dynamic array for where a dynamically sized array for this tile, which we've got through sorting, and we simply just go over. We get the array that goes through the pixel, and we'll get the array in. Sorry, the array origin in world space. We don't need a final color because it's not a color render, it's just an occlusion render. We need a closest hit, that is true. And then we're going to we'll need the screen dims. Maybe. Yeah, the scene dims. So obviously it's not multi-sampled, so we get rid of the multi-sampling. Multi-sampling just means basically do an upscaled render and then squish it all down at the end. So we're just taking all of that and condensing it. All right, let's figure out to make this into a single sampled renderer. Right, so now we get the ray which goes through the pixel that we're trying to render using a magic function. Then we change that from view space into world space. No accumulate alpha because there's nothing which should be transparent in this list. No such thing as a hit list. Go over all the ellipsoids. Do a rayverse. Move the ray origin and the ray direction into the local space of the ellipsoid. Do a rayverse ellipsoid in the local space of the ellipsoid at unit space. When it's a sphere, basically it's all been sort of like scaled back to a sphere. All we're looking for is probably T near, and we're looking for the closest hit. So what we're looking at doing is saying closest hit equals min closest hit and T near. None of this complicated stuff goes on. Right, it's just going to be far quicker. And we only write out depth instead of color, which means it'll be far quicker as well. We've still got optimizations we can make by reducing the size of the pixel, or the depth pixel is a 32-bit float. We could probably get that down to a 16-bit float in the future. But again, this optimizations future me can do. So what we write out at the end, to the depth texture, closest hit, and voila. So we'll call this shader, and we'll render that out into the lowest level MIP, which is the highest level resolution. Yeah, and then we'll look at the next problem that we need to solve after that. And as you start as simple as possible, a good way is to start reconstructing libraries from scratch. Will help string manipulation usually, because dealing with multiple logic stuff. Multiple logic stuff, right, okay. Yeah. The thing is that when things are a bit abstract, it's a bit hard for people, and when typically people get into programming and to learn making games, I think the easiest thing to do is just start trying to make a game and just try and make the simplest games. And that will also trigger that sort of enjoyment more for programming. And then I guess they can go and do things like create their own collections, right? Their own growable arrays and strings and string manipulation functions, right? because they'll find a need for it. And they'll be like, how do I do this better? And then they'll be interested. Oh, there's this, you know, and they'll ask around again and hopefully not get elitist advice. Yeah, if I'm rendering, what do I do for? I just use STB true type and I just have a fixed font atlas. I think it's like 4K squared resolution, and I just render them on the CPU and upload them to that font atlas when they're needed. It's quite a common approach. No, I'm not sure if he said games. Yeah, I'm not sure if he said games. I just assumed games because he came to this stream. And he didn't really respond after that. Right, let's launch this shader. So, occlusion ray tracer. I think I changed it to right only. I think I did. Neat. Neat. Yeah, I was thinking, the SDF stuff is cool and everything, but scientific field rendering is not for text. It's only really good for like world space stuff because you get to do stuff with like different MIP levels and that, and it's great. But if it's just on the screen, a scientific field rendering doesn't look good for small glyphs. So you're better off with a there's obviously ways around that, but yeah. You're better off with using just the classical approach. Although I have been thinking about ways of doing it all on the GPU anyway. I've got some ideas. But it's just more time to invest into stuff I don't really find massive joy in. So making game libraries, it makes you know what you need to support your game. Yeah, I guess so. Yeah, I think though the biggest criticism is Raylib is not how you would want to do it in the future. But yeah, that's still okay. But yeah, it does give you an idea of things, that is true. Right, I think we're there. So let's give it a launch and hopefully it doesn't What happened there? Model instances emit. Oh, did I delete the I? Well, 4133. Delete the I here. Cool. 45. Alright, here we go. See how this works. Right, so with rendering okay apparently for some reason. Thought I could have broke it, but so I haven't. Right, here's the occlusion texture. I do not see anything of substance in here. Let's hop open the profiler. It's running. Right, if I pause it and zoom in. So there's the occlusion buffer, we can see it, right? And everything underneath is just inside that scope, basically. So does the tile bending, then after that it's doing the occlusion ray tracer. Well, guess what? I passed in the depth texture and I didn't pass in the occlusion texture. So that's our mistake. So if we look at the depth texture, what we'll find out, let's get rid of the profiler, is that we actually rendered to it here. Occlusion ray tracer. Yeah, so there it is rendering there. I don't know what's going on. So there's the depth texture for the main render. Here's the one for the occlusion one. It's the wrong size. You know, there's tons of problems. So let's get back and give it the proper one. So what I would like to give it is occlusion texture ID. So see how that one works. Hey Alec, Happy New Year. How are you doing? Hope you had a good New Year. Occlusion texture. Right, so we're rendering something in there. It's a bit small, isn't it? But we are seeing something. Right, it's a bit weird because it's like in the top. Are we rendering in the wrong dimensions? Seems alright to me. So let's just write out. Let's just say right. Right, occlusion ray tracer. Let's just write out 0. I'm probably using scene dims, isn't it? I can see it now. I'm using scene dims in the... Oh wait, hang on a minute, I've just buggered it. Yeah, so I reckon what I'm doing... I'm using the scene dims, which is wrong. So the ray... Yeah, and it's rendering more pixels than it should. There's multiple problems here. So maybe the occlusion dims needs to get passed up via the globals. So we'll just do another one in here. So the occlusion buffer dims. So where we see that here with the scene dims, occlusion dims. Should have called that when I redid that, that's cool. So inside the graphics, right, have a good night, Rosema. Good to see you. And yeah, hope to see you in a future one. We're streaming tomorrow, back on the usual schedule. But yeah, hopefully see you then. If not, see you some other time. So we need to upload to the globals this value. So GGFX globals occlusion dims equals occlusion dims. Right, that should do it. Let's give that a go. All right, so if we hop into the texture viewer, looks even worse. Right. Right, we shouldn't have to sync on any of these irradiance things. Right, so let's go back to the shaders, and what we're going to do is actually just output 0 and see what happens. Right, so we wrote to every pixel there, so it means that something else is wrong. So obviously it's the tile it's getting the ellipsoids from is incorrect, so that it stays being infinity because this is 0. So yeah, something is clearly wrong. Yeah, I think it's that. Right, so let's say it's 16 by 16 for a screen tile. We've got the occlusion dims. Right. Is there anything hard-coded in these shaders to do with the scene? Can't see it anywhere. Oh, this one might be here. Damn it, it is. Right. So the one that bins the tiles into the... Sorry, bins the... Right. This would be the render dims, we'll call it. Yeah. So call it the screen dims. Right, we better. So if we change that out, or add this in, sorry. So that would be render dims, which would be... Oh, it's got to be passed in. No biggie. Maybe it could be the first parameter, you know. Right, GGFX is the occlusion. Well, no, it's local one, it says occlusion dims. This one is GGFX scene dims, that's the main render, the one that renders the actual models. .xy. Cool. Hopefully this fixes it. So see the occlusion texture. Right, it's better. We are seeing it show up, although they are looking a bit... It seems like it's in the right place. Right, so we get the ellipsoids there, then we show it. It's a little bit wrong. Ooh. It does need to be cleared every frame, I think. Oh no, it doesn't, because we write to the whole thing. Yeah, we write to the whole thing. Why is there 11 MIPS as well? Shouldn't there be 12? Oh, no, right. 12 is our max. We were 11 because we're under 4K. That's right. But that one's looking alright. You've moved the camera a bit though. Oh, I broke it. We rendered too many objects. And it broke. Okay, so I guess let's see if this shader is using this scene. It's not, is it? Right, so this just goes over all the models and emits all the ellipsoids, but eventually they will probably use the dimensions or something. But it doesn't yet. Right, let's see if we can look at this tile bin one and just see. I feel like it's still got some issues. Oh, maybe some of the tile binning stuff. No, because we've made it work. The tile binning stuff work for the surface and also the scene. Sometimes the scene renders a sub portion of the window. So that code is fine. Let's recheck this code. Right, so we're looking for something like scene. Still not there. What about this transfer? Right, the screen dims gets passed in. Let's double check. Scene. Right, nothing in there. Right, field of view. Ooh. No, view from what is fine. That's still in 3D space, right? It's nothing to do with the projection of the camera. So we could do some of the debug stuff. Let's see if that works. So you render to a texture. Problem is we don't have a texture which has the exact same resolution as the occlusion stuff. But we know that it works for the scene, but it's not working for the occlusion stuff. So maybe it's to do with the ray tracer then. Let's go back to that code. So right, this all seems okay. Yep, go over all the ellipsoids. Yeah, it seems like if there was a problem with this code when it selects the tile. Maybe. Yeah. Right, we could probably do our own debugging though and figure out what tile we are, and then probably do a shade based on that. So I don't know how many we have, but we can just do it like this. Oh, tile index, convert to a float. divided by, let's say there is, well, it's 15,000 divided by 16, about 93, then 800, isn't it? So it's about 93 times by 40. Well, maybe it's 800 divided by 16, wasn't it? 50, right? 90 times by 50, it's about 4,000 tiles. So if we say, let's put that number in there. So now we'll have our own debug view. We just open up the depth texture and just have a look at it. We should see it go across the x-axis, maybe in a 2x2 though. Something like that. Right. We can change the black-white levels. Because it's doing a max of 256. So it's going to, I think it's doing it in a 2x2, maybe. We could probably punch that into a, oh no, like a hash function, and then take that and use that as the throw into a hash function and divide by right. I've got like a GPU nice color function, so I pass in a random integer, so we'll say tile index. That just basically hashes it and gives me a color back, but we don't want a color, we want a single channel. So I can use the luminance function, which turns into a luminance. And then that'll be a single float. So that should hopefully yeah, we should hopefully see the tiles show up. Basically, it should be different. Oh. What's going on here? Oh, wait. Oh, right. That'll do it. Use LSP, please. Aren't I using LSP? Damn it, why did it crash? I think I rendered too many objects onto the scene, something dumb like that. Right. Cool, so we're seeing something here. Let's put it back to about 1. There we go. So we're seeing that there are tiles. Different tiles where you can see it in shades of grey. But they do look like they're different tiles, where no shade is exactly the same. Right? So they have got their own tiles. That's what we know. Yeah, I'm using an LSP, but I'm in my custom shader compiler, and I don't think it responds well to this. Sometimes it does. Yeah, it's able to do it. It's alright. BS there. Kind of helps sometimes. Right, so what else could be the problem? So it's only showing up in kind of the top right sometimes. Ah. No. It's all okay. I was thinking, could it be something to do with the tile binner? But the second one works, which is the rendering, just fine. I think the tile binner resets some of the local variables in the right place. It doesn't do it in the frame initialize anymore, I think. Oh, render ellipsoids count. That's going to be a bugger. So that could be causing a problem for the... right. Yeah. That's causing a problem for... the renderer, the main renderer actually, but not the occlusion render. So we need like a setup function for this, or shader. Just clears that out to 0. This is probably making it crash more than it was before, because this number just got too high. So let's give that a quick launch. We don't really touch anything other than global memory. Right, so don't think that's going to fix anything. That was really too concerned about. Worth checking anyway. See, I think when we was looking around, there's more objects that are rendering than there should have been, so that it was crashing more when I turned the camera. And I think that's all we've fixed. Yes, this is still not nice, right? If I was to move the scene... Well, that's interesting, we're getting some renders there. So we go to a very simple scene. If I press F1, it brings up the material editor. Still work in progress. But if I press the F9 here, you see the depth texture. Interesting, right? So the scene is this square image here, but the occlusion texture is actually not square, is it? It's kind of still a wide screen, so why is that? I thought I had a thing where I said... Oh no, I said if the MIP changed. I didn't say if the resolution changed, meaning that it doesn't actually match exactly to what the scene is. Right, okay, I see. So that's a problem. And it might be the thing that's causing the issues then. So what we need to do is say, not really if the MIP count changes, but really if the dimensions are different. So if any 32 times 3 are not equal, of occlusion dims and GFX occlusion dims. Something like that. Nice. Cool. Right, what will be next? Yes, I think that will be what we need. Technically, when we initialize this, it's not going to be what it is initialized to, which is one by one. So we should initialize this to one by one to match what the texture is actually going to be initialized to. Cool. Right, so let's give that a go and see if by changing it when the resolution changes, does it fix the problem? So if we open up the... Right, everything's shown up as black, which is weird. If I bring up the material editor, it's changed resolution there. Is it running every frame? I have suspicion that it's running every frame because it's black. No, you would see it show up in the history on the lower left in the texture viewer. Oh no, it is. There's a clear. There's a clear happening every frame, which means it's doing the resize every frame. But still, it's... Yeah, maybe this... Yeah, not sure. Yeah, that clear should be happening every frame. It seems like we're resizing every frame. If any are not equal. Ah, we didn't set it up. Whoops. GFX. Nice. Right, so check out the occlusion texture. See, now it's not being cleared every frame. So, right. We change the far value, basically the white point, which deemed as white. Yeah, then I move it around. It's just weird. Okay, if we bring up the material editor, we're seeing this, it's flickering though. Also weird. There's actually flickering happening here now. Actually no, it's probably my monitor's been messed up. It does that sometimes. So we get intense flickering. If I was to view the scene. Oh, maybe it's not my monitor. Oh no, it is my monitor, I can see it. You probably can't see that flickering, that's okay. Yeah, so I'm not seeing any flickering here. Right. But this is flickering, look at that, oh my days. Why? So black would mean 0. White would mean... Nothing flickering on stream. Oh, that's bizarre then. Thanks. This is really flickering for me. But yeah, I wonder why if non-zero. I don't know what that is then. But yes, this is black, meaning that. Oh, interesting. Oh, now this won't go. It's visible here. It's flickering for me. It's in my monitor. My monitor does this. It goes when I turn it off, though. I have an idea. I think what I'm doing is I'm encoding -1 into the. Oh. Yeah. So I didn't check for a miss. I just. Okay. If hit. Not really a hit if that's the case. Right, so what is it again? So if T near, he'd be inside. Yeah, something like that. So I wasn't checking if that. So if T near or T far, so that's like the hit on either side of the ellipsoid. When you do a reverse ellipsoid, so you have your ellipsoid, you got your ray, T near, T far. So it's the distance along the ray, isn't it? So I wasn't checking if it was actually in front of the camera position. So what was happening is it was allowing stuff which is behind it or misses. So those would then get encoded in there as the minimum, and therefore they're shown up as black. So that's maybe what the problem was. Or the final problem, right? Maybe that's the final problem. Oh, it's flickering like crazy. Is this flickering? I wonder if I've got anything smart on my monitor which is causing it. Now my whole screen is flickering. I wonder if anything that's smart on my monitor. Response time fast. Async pro premium. What the? Yeah, I wonder if there's something I can change in the monitor settings, which you guys obviously can't see this. Yeah. Right, fair enough. It's not flickering. That's very bizarre. So the only thing I can do then to know if it is actually flickering is let it flicker. Oh. And let's get it off the screen. I could do some hover. Yeah, I've got do some shader code. That's what we'll do. So we'll say if mouse is in, if is mouse at. So what I say is pixel coordinate. So let's scale this up. U coord multiplied by 2. Is it an int or something? Yeah, good. Yeah. So if I say scale that by 2, please, and then I can say right, GPU hpref. We'll just say depth. All right. So I had to scale it by 2 because the occlusion dims is half the resolution. So it'll roughly be right. So we'll hover over somewhere basically and see a value every frame, and it should Yeah, it's flickering. I don't know where it's gone now though. I'm not seeing it render anymore. That's all the value show up depth. There you go. Oh, when I press escape, it stops. Why? Alright, so I can't press escape. That changes the mouse mode. But I can put it back. Right, it flickers between infinity and not infinity. So I think I'm displaying at 30 FPS, but my monitor's at 60. So it might... something like that's going on. So you guys are not getting the flicker. Bit weird. So that must mean maybe the ellipsoids count is being set one frame and not set the next frame. Right, so clearly that is fine. It's not a flickering valley, the depth stays the same. Interesting. We could look at the profiler and see if that helps us figure out what's going on. It's weird when I press escape, the debug print stopped going off. Just for that one as well. Weird. Yes, there's the occlusion buffer thing there. Right, 0.4 milliseconds to render that whole thing. Maybe we could try some optimization, see how much we could reduce it. Well, it was doing 40 ellipsoids actually, so that would go down, hopefully over time. Yeah, I don't know what would... well, so it's stable the number of ellipsoids, which means that the ellipsoids themselves must not be the same every frame. So what's probably going on then is the sorting code is getting messed up. Well, this one should allow transparency. I forgot about that one. That's not the problem. So we put... The number of ellipsoids is the same. So the buffer that gets the this render ellipsoid buffer. That gets populated by right by the shader here. And we read from it in the ray tracer as well. So we clear that to 0. Where else is it used? Not many places. All right. So I guess we can scale it back to a single ellipsoid and then check out those values there. So the best way to do that is, well, we're never going to get a single ellipsoid. We'll get 2. So if we put some print statements in the shader. So yeah, this one's not flickering here, but it wasn't in the previous one, right? Go to the occlusion test, flickers. Well, I can see it flickering. So in the shader code, here we will know that there is this here. So I guess we could print out T near. Ooh. If far, you don't need to be negative, that's the issue, isn't it? Max 0. Sketchy, but I don't think that's the problem. Let's try that out. Still don't know why over press escape it stops doing it. Right, so it's flickering between 2.1 and then -1. So -1 meaning not a hit, right? Cool. So clearly something, we'll just find the thing that changes every frame. So if we take the if we take something to do with the ellipsoid, can I take the translation and say the X component to see if that changes? Right, so the X component stays the same. Of the transform. It's going to be a lot of little floats to print out. Yeah, the transform is probably going to stay consistent. Should probably have a function which helps print out matrices. Right, let's just do three at a time. We can come back and change it for each of the axes in a second. So let's just look at the translation. Right, it's pretty consistent there. They're slightly different translated, one is a bit taller and all that. That's fine. If we look at axes 0, let's see if that one flickers. Right, nothing's flickering with those values between frames, which is great. Try ones out. So that's very bizarre. So which means it must be another value, not the ellipsoid itself, which is changing. Right, that one was fine, it's not flickering. Which means it's probably... Huh. Right, interesting. So I guess then, what flickers is maybe the ray direction or the ray origin. Let's try the local space one first, just to see. Right, that flickers. Ray direction flickers. Are we not uploading? Interesting. So does my occlusion dims flicker? It can't, right? Because if that flickers then... Or that's... Oh. Another problem. Okay, so basically I have a globals buffer. The globals buffer is there's technically there's two of them. There's one for one frame and one for the frame after, and we swap between them because they're uploaded to from the wait, is that true? How does it work again? Yeah, I think there's two of them. And it does either if switches between them, so you upload one from the CPU while the GPU is reading from the other one, which might actually not be the best way to do it. We might be better off uploading it instead. I don't know why I've done it that way, thinking about it. So what's happening is I'm not setting it every frame. So basically it flickers, right? It changes every frame, so that's the problem. So that fixed the problem, right? We weren't setting the global in the buffer every frame, so that's cool. So it seems like we've fixed all the issues now. Nice. So we pan around, we're seeing the depth rendered out. If we change the white point, you see a little bit more, a little bit softer. So let's bring in the full scene again. So into game.c, not much of a game, but there you go. And we'll have a richer, whatever you mean by rich, a richer depth value being recorded out to the occlusion texture. Nice, look at that. So, yeah, as you tell, so it's darker nearer and then more lighter further away. Cool. So this is at half resolution, and the time it takes to render that is 0.64 ms compared to 1.82 ms for the full screen one. It's still going over a lot of ellipsoids. You know, we could probably benefit from, it's taking a millisecond to do an occlusion buffer thing here. We've still got to downsample it. That's the thing we'll do next. But I'm hoping it'll help reduce this one. But yeah, we could probably optimize this further and pack our depth down to a U16. We could try that out and see what happens. Since we're not actually using it yet, let's just quickly, well, actually no, because we can't tell. We'll have to get a very reproducible scene. So that's reproducible. Right, 3 point. Yes, that's reproducible. We can quickly change it and just see. Right, 0.37. So if we take the graphics occlusion texture, if we change that to a 16 uint, so we'll pack it down something like that in the future. If we then in the shader code find the occlusion thing, we'll write it to a 16 uint, and we'll just write out this as uint bits 2, I think I'll call it. Yeah, bits from U32, so I'll make it into a uint. It's completely wrong. You would like properly pack it down into a fixed point number, but it's just a test. So we've got to change it in another place, and that's here to a 16 uint. Cool, so that should hopefully work. Then we can do a performance test. Right, so that didn't seem to make a difference there. That number's exactly the same. So we don't seem to be bound by writing out a smaller texture, that's for sure. Maybe. Yeah, that's interesting. I thought we would get some increase there. So using a full-on 32 is not... Huh. Weird. Yeah, so the way we would... So, you know, I guess, say if we broke at the first hit, how much quicker would that be, right? Right, so that knocks it down into a very small 0.09. So obviously we'll get this sort of flickeriness because of the Z fighting. So they are sorted front to back, but it's very rough. There's probably ways we can improve that. But yeah, when we do this big old scene here like this, it's about 0.25 ms. For that, which is not that bad. We want this to be as cheap as possible. So yeah, maybe. Yeah, maybe just rendering the first ellipsoid might be good enough. Maybe. Even though it could be one which is technically a bit further back. Yeah, maybe that's all right. Because it's just got to be, it's a rough guess. So maybe we just say, right, get the first ellipsoid. No, you might do a miss, actually, sorry. Yes, you keep going. Closest hit, be T near max 0. Yeah, that'll be good. So that would mean that it's probably wrong, but it's good enough. Yeah, it'll be wrong if ellipsoids overlap. Cool. Right, so we did quite well today. Let's see the list. So we created the texture with the full MIP chain, but we haven't actually initialized the MIPs yet. We've tile binned them, but we've not done the occlusion test with the previous depth, with the previous frame's occlusion buffer. That will come at the end. We've got to actually produce the full, do the full occlusion testing before we can do that. We ray trace at half resolution and write out to MIP 0. We've just got that working. The next thing to do is do a down sample to all the lower MIP levels. So we'll look into doing a shader for that tomorrow. We'll be starting about 4. Yeah, about was it 3.5 hours ago tomorrow we'll be doing it. Tile bin. Yeah, tile bin all the ellipsoids that passed the new occlusion test. Again, we'll do that tomorrow as well. So we might be able to get this all working by tomorrow actually, and see how much of a benefit this actually pays off, this approach, and if we can do anything else to make it better. But yeah, awesome. Right, let's find someone to raid. Hopefully someone to raid. But yeah, in the meantime, if you want to come and hang out and chat offline, feel free to join the Discord. Thank you for everyone who's supporting the channel. Appreciate you guys. Appreciate my supporters. But yeah, if people are going back to work tomorrow, I hope you guys have a good start of your work week. Cool. Right, I'll see you all in the future one. Hopefully catch you guys tomorrow. If not, have a good weekend. See you then.